Tonight it is my pleasure to welcome Dr. Jessy Jordan, who's a professor of philosophy at Mount St. Mary's, specializing in neo-Aristotelian natural normativity. He's also the director of the Mount's Common Integrated and Sequenced Liberal Arts Core Curriculum. He's published numerous articles on moral philosophy and is currently finishing his book, An Introduction to the Meta-Ethics of Virtue Ethics on Transcendental Aristotelian Naturalism. His lecture is entitled, What Was Lost with the Rejection of Aristotelian Physics on Motion and Moral Philosophy. Please join me in welcoming Dr. Jordan.
Thank you for that warm welcome. On the eve of the Annapolis Cup, I'm particularly honored that you are here, as I imagine that you have preparations to be doing. Let me begin with an autobiographical note. When I first read the portion of Aristotle's Metaphysics, in which he reviews the opinions of his philosophical predecessors, I resonated deeply with his description of Socrates. Aristotle relays the following delicious tidbit about Socrates' philosophical practice. Socrates, however, was busying himself about ethical matters and neglecting the world of nature as a whole. I felt seen. Yes, this is exactly the justification I was looking for. I thought to myself, right, I'm just like Socrates. What I really care about are ethical questions. And, like Socrates, I can neglect the world of nature, what the Greeks would have called physis, or physics. I mean, really, why were so many of those ancient thinkers always banging on so much about motion? The exciting philosophy was ethics, wrestling with questions like, what is the best life for the human? And whether we have better reason to be unjust than just, and whether virtue is necessary for happiness. I was largely uninterested in reading philosophical accounts of motion, and Socrates, that beautiful philosophical trump card, was on my side. 25 years later, though, and with all due deference to Aristotle's Socrates, I've come to think it might be really important to bang on a bit about motion. And this is precisely because I've been busying myself with ethical matters for the better part of my life. What I hope to shed light on this evening is the following hypothesis. How we think about moving objects has profound consequences for moral philosophy. More specifically, I hope to shed light on how the early modern rejection of Aristotelian physics and its alternative mechanistic view of motion has far-reaching consequences for how we think about moral philosophy. What I hope to illumine is how it eclipses a way of thinking about moral judgments that is as objective and as descriptive as the evaluation that Hoots the owl is defective if it lacks sharp night vision. Before we proceed, let's pause and think about that last judgment for just a moment. Hoots the owl is defective if it lacks sharp night vision. The first thing to notice is that it is an evaluative judgment. Note the language of defect and its contrast, soundness or goodness. We are dealing with the language of natural defect and natural goodness in the context of judgments about living things. Second, notice that such natural goodness evaluations seem to be matters of fact, not the mere subjective expression of someone's attitudes or the projection of value onto nature, gilding or staining all natural objects with the colors borrowed from internal sentiment in David Hume's memorable formulation. To say that Hoots is defective in this way is straightforwardly descriptive statement about how a certain part of reality is as a matter of fact. Now consider briefly two additional claims. A human needs the virtues, just like an owl needs night vision. Humans, like owls, are defective if they lack the virtues. My aim in this talk this evening is not to defend the claim that humans are naturally defective if they lack the virtues. Instead, it is to try to highlight how the rejection and replacement of Aristotelian physics with an early modern mechanistic one undercut a way of thinking about evaluations that saw them as straightforward matters of fact. What we will need to do to see this, though, is to try to see moving objects in the way Aristotle saw them, and then, by contrast, to see motion in the alternative way that the early modern mechanistic philosophers did. Now, maybe for you Johnnies, I don't need to do much more to generate interest in such a topic. After all, your curriculum includes a large dose of natural philosophy in which you think a lot about motion, including all those hands-on, motion-oriented experiments you do in freshman and junior lab. And indeed, the architects of the St. John's curriculum seem very keen to compare and contrast the conceptual worlds of the ancients to that of the moderns, to try and bring out the essential difference and to highlight what those conceptual frameworks reveal, and perhaps more importantly, what they cover up. I'm thinking of Johnnies like Jacob Klein, who with ever greater precision tried to grasp the nature of our modern scientific consciousness and the fundamental conceptual shift which took place in the modern era. Although Klein might fault me for the overly common sense approach I will be taking, I hope that my reflections tonight might also help us grasp this conceptual shift more adequately. Before going any further, though, perhaps it might be helpful for me to lay at least some of my cards on the table. Despite my nostalgic-sounding title, I don't think it is really possible or advisable for us in our current age to attempt a wholesale retrieval of Aristotelian physics, reconceptualizing all motion along Aristotelian lines. We can't turn back the clock. For instance, I take it that we can no longer understand a falling stone as striving to reach its natural place at the center of the cosmos. We think, and rightly so, that what explains such motion is gravity. I'll come back to this later. But what is important for now is for me simply to clarify that, nostalgic titles aside, I am no modernity knocker and will most certainly not be advocating a thoroughgoing revival of Aristotelian physics. Whatever conceptual space we might hope to carve out for an Aristotelian moral philosophy, it must sit downstream of Newton and Kant, of Galileo and Darwin. Thankfully, though, I don't think this requires thinking of all motion in entirely non-teleological mechanistic terms. Okay, let's now set aside some of these mile-high considerations and try to get down to the task of seeing moving objects as Aristotle did. Then we will attempt, by contrast, to imagine what it is to regard moving objects in the way the early modern mechanical philosophers did. That will put us into position to see more clearly what was lost with the rejection of Aristotelian physics and what in the world that has to do with moral philosophy. Let us begin, though, with some examples of moving objects and with some initial contrasts between Aristotle and the early modern mechanistic philosophers of motion. Consider the movement of Sisyphus's boulder. You remember, of course, the tyrant Sisyphus, who angered the gods by violating an ancient Greek tradition of hospitality toward foreigners and guests, and was thus condemned to roll a boulder to the top of a hill where it would then roll back down. The punishment was that Sisyphus was required to repeat the action eternally. Whether we can imagine Sisyphus happy or not, our attention should be on the movement of the boulder rolling down the hill in this story. Now consider a very different moving object. What we have here is a time-lapse video of the life cycle of a sunflower. Really beautiful, right? But also rather melancholy there at the end. Without much interpretive commentary at this point, let me just highlight the following central contrast. With the sunflower, we have the movement of a living thing, whereas with the boulder, we have the movement of an inanimate object. Consider two more moving objects. Imagine that you are at Camden Yards in Baltimore for an Orioles game. As a part of a spectacle to promote its work protecting birds, a national Audubon representative releases 24 Orioles from home plate. All of the birds fly out of the stadium off into the horizon in search of food. The relevant motion here is the bird flight. Now consider a different sort of bird flight out of the stadium motion. And I should caution you, it's not going to be pretty. Imagine in protest to the work of the Audubon Society, shortstop Gunnar Henderson steps up to the plate with a bound cardinal in hand, tosses it up, and hits it out of the park. Here we have a batted out of the park flying motion. Please rest assured, no animals were harmed in the making of this example, and I'm sure this is not something Gunnar would do. Again, without too much interpretive commentary regarding the two different bird movements, we are tempted, I imagine, to say that the Orioles are moved by an internal principle of motion, whereas the cardinal is moved by an external or violent principle of motion. Okay, so we have 4 cases of movement: Sisyphus's boulder, a growing sunflower, flying Orioles, and a flying cardinal batted out of the park. Now, if we were sitting in a seminar right now, this is the point at which I would love to slow down and have a conversation about your intuitions regarding these cases. But we're not. This is a lecture, so I will have to supply what I assume are your intuitions and risk moving too quickly. You should know, though, that your intuitions are not naive. They have already been profoundly shaped by the particular place you occupy in the history of thought. A comparison between our intuitions, Aristotle's, and the early moderns will display this. Common sense is always already a historically affected thing. Now here's an interpretive description of these moving objects I think you will find intuitively plausible, indeed that you may even find irresistible, being situated historically as you are. Sisyphus's boulder rolls down the hill, ultimately due to gravity. This is no internal principle of motion within the boulder, as if it was striving to reach its natural place in the universe or actualize its nature. The boulder has no natural place. It moves because of the external force of gravity acting upon it, which is, as we all know, the universal force of attraction acting between all material objects, the strength of which is proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Gravity not only explains the movement of the boulder, but also the movement of astronomical objects like the planets. The planets move as they do, not because of their nature, or because they have a natural place in an ordered cosmos, but because, as an entirely contingent matter, they have fallen into a homeostatic relation with one another, remaining in their orbits due to their external relation to other large bodies, as described by Newton's law of universal gravitation. The growing sunflower, by contrast, although acted upon by the force of gravity, also has an internal principle of movement, a nature that is being realized, unfolding, flowering, if all goes well. As a living thing, the sunflower is different from inanimate objects like boulders in that it develops through stages toward an end goal. The movement of the inanimate boulder is different from the vital movement of the sunflower, which is fundamentally developmental in character. To speak of a genuinely developmental movement, and not just a change from one state to another, is to see that process as a unity of stages that unfolds toward an endpoint, a telos. I'll say more about this kind of movement, the movement of a living thing, when we turn to Aristotle more properly in a moment. But the thing to take note of here is that when it comes to living things, we are all still Aristotelians. Notably, though, we don't think of boulders or billiard balls, inanimate objects, in these terms. When they move, it is due to an external force operating upon them, not an internal principle that is unfolding toward a telos. How about the movement of the flying orioles and the flying cardinal? I think you would find something like the following description intuitively plausible. The Orioles are flying out of the stadium due to an internal principle of movement, whereas the Cardinal is flying out due to an external force, gunner's bat. The Orioles' flying is self-directed. The Cardinal's is not. The movement of the Orioles is a natural movement. It's the sort of movement that is characteristic of their life form, an expression of the actualization of their nature. The cardinal's movement is an unnatural, violent motion imposed upon it by an external force. Something very close to this interpretive description of our four cases is what I think we would tease out together if we were to have a conversation about our intuitions regarding these cases in a seminar. We should highlight two salient features of the description. One, it distinguishes sharply between the movement of living things and that of non-living things. And two, it assumes that there is a genuine difference between natural motion and violent motion. These two features might strike us as so obvious that they are not even worth highlighting. But the plot begins to thicken when we note that neither Aristotle nor the early modern mechanistic philosophers would affirm such a sharp distinction between the movement of, say, boulders and that of sunflowers, although for different reasons. And when we note that the early moderns, for their part, adopt a philosophy of motion according to which, in an ultimate sense, there is no genuine natural motion. Every motion for them is a violent motion, at least qua mechanistic philosophy. Regarding the motion of living and of non-living things, let's call them respectively vital and non-vital motion, Aristotle seems to have thought of all motion as more or less vital motion, not in the sense that he didn't distinguish between living and non-living, but in the sense of the underlying explanation for motion. The early modern mechanistic philosophers, on the other hand, seem to have thought of all motion as non-vital. Aristotle, that is, seems to have thought about falling boulders in the same way he thought about growing plants, utilizing and extending vital explanatory categories to the movement of inanimate objects, categories such as potentiality, actuality, nature, telos, and natural place. Oppositely, early modern mechanistic philosophers seem to have thought about the movement of blooming flowers in terms of explanatory categories we would apply to inert, non-living objects in motion. For what it's worth, I, anyway, think Aristotle was wrong about falling boulders, and the early moderns were wrong about the blooming flower. And if I'm right about our common sense intuitions, so do you. We, unlike Aristotle and the mechanical philosophy of the 17th century, do not have a unified account of moving objects. We think that the explanatory categories needed to account for vital motion are different from those needed to account for non-vital motion. Let's now turn to the apparent difference between natural and violent motion, Orioles versus the cardinal. Aristotle affirms it, whereas the early modern mechanistic philosophy regards it as illusory, as all motion is ultimately violent. Here, mechanistic philosophy really seems to conflict with the appearances. The Orioles really seem to move in accord with an internal principle of motion, whereas the cardinal seems to be moved by an external force. To see the flight of the Orioles as an early modern mechanistic philosopher, it would ultimately be to try and reduce this motion down to directionless, neutral atoms bumping into one another, externally exerting force upon one another, just located within the bird. Think about billiard balls on a table, or croquet balls rolling across the field. The balls don't have a natural inner tendency to the corner pocket, as if they are actualizing some inner nature when they move to the corner pocket. Mechanistic philosophers think of the flight of the Orioles like this, as explicable in terms of something like a game of billiards going on inside the bird, ultimately reducible to a collection of directionless atoms knocking around. We'll come back to this billiard ball picture later, but for now, what I hope to have done so far is simply to have helped us begin to fix some examples of motion richly and firmly in our minds, and to draw our attention in a preliminary fashion to some important contrasts between Aristotle, early modern mechanistic philosophy, and ourselves regarding two concept pairs. One, vital and non-vital motion, and two, natural and violent motion. Let us now turn to the Aristotelian account of motion in more detail in order to imagine more fully how Aristotle saw moving objects. Now a section Aristotle on motion. In my attempt to really come to terms with the difference between the ancients and the moderns on motion, I have been enormously helped by two histories of science, especially Stephen Shapin's The Scientific Revolution. Of course, there is no replacement for reading primary sources and whole books, something you Johnnies are already disposed to affirm. But if you want to bring things together in a big picture sort of way and begin to grasp more adequately the fundamental conceptual shift which took place in the modern era, it is very difficult to do so without some sort of expert guide to help. At the risk of saying something heretical here at St. John's, if you want a big picture understanding of the transformation ancient science underwent in the 17th century, a transition St. John's own Jacob Klein called unique and unparalleled in the history of man, I would advise that you reach for some good intellectual histories, and I especially commend Shapin's book on the scientific revolution. Shapin's book contains one of my all-time favorite opening lines. There was no such thing as the scientific revolution, and this is a book about it. More to the point, though, when discussing Aristotle on motion, Shapin writes the following, and this really is the crux of the matter. For Aristotle and his followers, all natural motion had a developmental character. This is the central thing we need to understand. We need to get a clear sense of what it means to see all natural motion, whether boulder or bumblebee, in developmental terms. To do so, let's review some salient features of Aristotle's natural philosophy. Aristotle adopted the view originally proposed by Empedocles and subsequently adopted by Plato that terrestrial matter was made up of four elements: earth, water, air, and fire, and that heavenly bodies were made up of a fifth element, the quintessence, or ether. As Shapin relays, each of these elements had its natural place, and when it was at that place, it was at rest. Earth and water are heavy elements, and they can be at rest only when they are at the center of the cosmos. Air and fire have a tendency to rise, and their proper spheres are above the earth. For Aristotle, the elements each had its natural motion, the way it was in its nature to move. For the element of earth, the natural motion was to descend in a straight line toward the center of the earth. And this it will do unless the earthy body encounters either an obstacle that blocks its path or a push that acts on it in another direction. Natural motion tends toward natural place. Aristotle was, of course, well aware that all sorts of non-rectilinear motions occurred. These were called violent motions, motions against the nature of a body, to be accounted for by the action of external forces, such as might be imposed on a stone by a person's throwing it upward or parallel to the ground. As historian of science David Lindbergh elaborates, because earth and water are heavy, it is their nature to descend toward the center of the universe. Because air and fire are light, it is their nature to ascend toward the periphery. If there were no hindrances, therefore, earth and water would collect at the center. Because of its greater heaviness, earth would achieve a lower position, forming a sphere at the very center of the universe. Water would collect in a concentric spherical shell just outside it. Air and fire naturally ascend, but fire, owing to its greater levity, occupies the outermost region, with air as a concentric sphere just inside it. In the ideal case, in which there are no mixed bodies and nothing prevents the natures of the four elements from fulfilling themselves, The elements would thus form a set of concentric spheres, fire on the outside, followed by air and water, and finally earth at the center. But in reality, the world is composed largely of mixed bodies, one always interfering with another, and the ideal is never attained. Nonetheless, the ideal arrangement defines the natural place of each of the elements. The natural place of earth is at the center of the universe, of fire just inside the sphere of the moon, and so forth. Notice that the foregoing descriptions of Aristotle's cosmology make continual reference to one of the most fundamental aspects of Aristotle's theory of motion, namely its distinction between natural and violent motion. Once again, for Aristotle, natural motion is motion toward the natural place of a moving body. It is the way it is in a particular body's nature to move. And again, by contrast, violent motion is motion against the nature of a body, to be accounted for by the action of external forces. In this context, we can ask ourselves what it really means to see Sisyphus's boulder or the falling of an elevated stone through Aristotelian eyes. Well, for Aristotle, the falling of an elevated stone is a natural motion. When we see a stone falling, what explains that particular movement is that the stone is striving toward its natural place at the center of the universe, moving so as to fulfill its nature and not under coercion from an outside force, a force like, say, gravity. Remember, Aristotle defines nature as a principle or cause of being moved and being at rest, and explains that each thing possessing a nature has within itself a principle of motion and of stationariness. Of course, to speak in terms of a stone's striving toward its natural place at the center of the cosmos is not to suggest that the stone has some kind of conscious intention that explains its movement. To suggest such a thing would be to mischaracterize radically Aristotle's actual position. To say, though, that a stone is striving toward its natural place at the center of a cosmos is to see that movement in fundamentally developmental terms. That is, to see it as a self-directed entity unfolding toward its telos, or equivalently, as striving to actualize its potential, or equivalently still, to fulfill its nature. Now, I'm sure it's not lost on you Johnnies that we have begun speaking in familiar Aristotelian terms, utilizing the interlocking concepts of potentiality, actuality, nature, telos, and natural place. But these categories of explanation seem to be most at home in biology, most at home, that is, when trying to comprehend living things. Listen to the following Aristotelian way of speaking about the growth of our sunflower. Vital growth, by the way, is a concept that is fundamentally developmental in character, and as such represents a sequence of events as possessing a certain unity that unfolds toward an end point, a telos. So to call a specific process or movement a developmental one is to see it as unfolding toward some telos. Consider our sunflower. If all goes well with its growth, that is, if all goes according to nature, our sunflower seed will develop, moving through the stages of a sunflower life cycle: planting, germination, leafing, budding, flowering, pollination, seed development, and seed dropping. Notice, if such a developmental process, motion, were to get interrupted, say the planted seed gets eaten by an oriole, a motion we, with Aristotle, might call violent, we say that it did not have the opportunity to actualize its full potential or realize its nature. The notion of a developmental life process being interrupted is crucial here. For to be an interrupted developmental process, a certain sequence of events must possess a kind of unity that fails to reach its telos or goal or endpoint. Life forms naturally move to fulfill their natures unless interrupted by an external or violent motion working against it. Natures here are understood as internal endpoints toward which developmental life processes are tending. As such, natures act as internal principles of motion with genuine causal powers. Organisms are not, on the Aristotelian analysis, inert material objects acted on by external forces. So again, the Aristotelian categories of potentiality, actuality, nature, telos, and natural motion seem to be most at home in biological contexts of explanation, and especially when representing a sequence of events as a developmental life process. But for Aristotle, just like organisms are not inert material objects merely acted on by external forces, neither are inorganic objects like earth, water, air, and fire. The growth of a sunflower and a stone's fall are both examples of natural motion according to which an object is striving to actualize its nature and move to its natural place. Aristotle, it seems, conceived of the motion of all natural objects, whether living or non-living, on the model of biological explanation. The stone's fall or the boulder's roll, like the growth of a sunflower, is developmental. This is what it means to say that Aristotle saw all natural motion in distinctly developmental terms. Aristotle utilized the categories of explanation most at home in biology and extended them globally in an attempt to provide a unified account of all motion. Aristotle's physics was an attempt to understand all motion on a fundamentally biological model. Chapin expresses this point particularly well. For Aristotle and his followers, bodies naturally moved so as to fulfill their natures, to transform the potential into the actual, to move toward where it was natural for them to be. Aristotelian physics was, in that sense, modeled on biology and employed explanatory categories similar to those used to comprehend living things. Just as the acorn's development into the oak was the transformation of what was potential into what was actual, so the fall of an elevated stone was the actualization of its potential, the realization of its nature. Did you catch the really crucial line? Aristotelian physics was modeled on biology and employed explanatory categories similar to those used to comprehend living things. This, again, does not mean that Aristotle thought stones were alive or possessed conscious intentions. It does mean, though, that he thought about a falling stone in a radically different way from, say, Newton or from us. We are people who think that the explanation of the stone's movement is the external force of gravity. People who do not think that a stone is striving to reach its natural place at the center of an ordered cosmos. Great big stones, like, say, Earth or Mars, do not move the way they do because they have settled into their natural place in the cosmos and are at rest in the sense of actualizing their nature, but because of their contingent position in relation to other objects governed by the universal force of gravity. I hope I've said enough about Aristotle's cosmology and physics to enable us to imagine and comprehend the moving world as Aristotle would, and I certainly hope I have done so accurately. To summarize as briefly as possible, imagining the moving world like Aristotle would be to see the movement of falling stones just as one might see the movement of sunflowers, utilizing explanatory categories distinctively suited to comprehending vital movement, developmental movement. Such a vitalist paradigm is one that, on the one hand, honors our common sense distinction between natural and violent motion, but on the other sits rather jarringly with our modern scientific consciousness when it comes to the explanation of non-vital motion. Now a section on early modern mechanical philosophy and motion. The foregoing Aristotelian cosmological picture is radically different from the atomism of ancient philosophers such as Leucippus, Democritus, Epicurus, and Lucretius, and also their early modern heirs, defenders of the corpuscularian or mechanical philosophy, such as Johannes Kepler, Galileo Galilei, René Descartes, Pierre Gassendi, Francis Bacon, Thomas Hobbes, Robert Boyle, and Isaac Newton. These early moderns advocated a mechanistic universe of lifeless, indivisible atoms moving randomly in an infinite world. Many of you Johnnies are already familiar with this atomistic, anti-teleological, and mechanical cosmological picture, as you have the great good fortune at St. John's to read Lucretius's beautiful and even elevating poem on Epicurean physics, De Rerum Natura. It's all there, that great reductive attempt to provide an account of motion and the universe without essential appeal to natures striving to actualize their inner tendencies, or without appeal to that companion concept, telos, but instead to neutral, inert, micromechanical atoms bumping into one another. On this picture, what is really underneath all motion, living and non-living alike, is a microscopic world of something like indivisible, natureless billiard balls and their purposeless collisions. Listen to how one commentator expresses the contrast between this and the Aristotelian picture. We moderns tend to think about nature and frame our theories in terms of inert material bodies acted on by outside forces. Our paradigm, since the early modern period, has been billiard balls on a table. Aristotle, by contrast, was a biologist first to last. Even when doing what he called physics, and especially when doing ethics or political science, he thought in terms of organism, like plants. Billiard balls don't move to the corner pocket because they are actualizing an inner tendency or nature, as if they are developing towards some end. Billiard balls do move to the corner pocket because of an external or violent force exerted upon them. The motion of billiard balls is properly understood as violent in Aristotle's sense, because what explains it is not the internal unfolding or development of a nature toward its telos, but the action of purposeless external forces. An attempt to explain all motion in billiard ball terms, then, would be one that regards all motion as, at bottom, violent. Everything is, as it were, a chain reaction. It is a cosmological picture that is fundamentally anti-teleological and non-developmental, regarding all motion as ultimately random, and rejecting the notion that any object has a natural place. The grand ambition of some of the highest profile early modern natural philosophers was, in the great tradition of ancient atomism, to provide causal explanations of all natural events in terms of how natureless, neutral, micromechanical objects relate to and bump into one another in a giant chain reaction of external forces. One way to bring out the basic difference between Aristotle and some of the early modern defenders of the mechanical philosophy is to mark an important distinction between genuinely developmental processes on the one hand and chain reactions on the other. A chain reaction is not a developmental process unfolding toward a telos. Early modern mechanical philosophers, qua mechanical philosophy, regarded all motion as a chain reaction. This helps contextualize the ubiquitous early modern appeal to the clock metaphor as a way to construe natural processes. Listen to just two early moderns in their own words. Johannes Kepler writes, "My aim in this is to show that the machine of the universe is not similar to a divine animated being, but similar to a clock." Robert Boyle affirms that the natural world is, as it were, a great piece of clockwork. Think about the inner workings of a clock for a moment. Why do the hands move? One gear moves, exerting external force on another gear, causing it to move, and then it in turn causes the motion of another gear, and so on in a mechanical chain reaction until we ultimately see the hands move as a result of their physical contact with those gears. This motion is not the internal unfolding or development of a nature actualizing its telos. Rather, it is a chain reaction, like billiard balls. We should not pretend, though, that every early modern mechanical philosopher was united in the thought that mechanical explanations could account for all natural phenomena. There was a healthy debate regarding the limits of mechanical explanations, with many adherents understanding their role as mechanical philosophers as merely offering material and mechanistic explanations where they could, and where they could not, to acknowledge its limits. Indeed, many of these early moderns thought that a thoroughgoing mechanical philosophy could not properly account for living things. Boyle, for instance, arguing for the proper role for non-mechanical and teleological explanations in the understanding of living things, writes, "There is no part of nature known to us wherein the considerations of final causes may so justly take place as in the structure of the bodies of animals." Others, however, in their more aggressive moods, sought to explain not just some natural phenomena in mechanistic terms, but all of them. Chapin relays how Descartes, for instance, in his Principles of Philosophy, 1664, took on everything in nature: the gravitation of bodies, the behavior of liquids and magnets, the causes of earthquakes, chemical combination, the movements of human bodies, and the bases of human sensation, and so on, and concluded by affirming that there is no phenomenon in nature whose treatment has been omitted and that cannot be accounted for by mechanical principles. We hear echoes of this aggressive Cartesian mood in Thomas Hobbes's introduction to the Leviathan. Hobbes writes, "For seeing life is but a motion of limbs, the beginning whereof is in some principal part within, why may we not say that all automata, engines that move themselves by springs and wheels as doth a watch, have an artificial life? For what is the heart but a spring, and the nerves but so many strings, and the joints but so many wheels, giving motion to the whole body, such as was intended by the artificer?" The less aggressive early modern mechanistic philosophers, though, were always skeptical of the grand reductive attempt to understand all motion in mechanistic terms. They remained skeptical, that is, of the totalizing mechanistic projects of a Lucretius, a Descartes, or a Hobbes. Such a reductive cosmological picture always struggled to give satisfactory explanations of vital motion. The great hope was to push the chain reaction billiard ball account inside living objects, accounting for the apparently goal-directed movement of living things entirely in terms of the micromechanical random movement of directionless and purposeless atoms. But we might ask, can the phenomenon of vital motion be reduced to and redescribed in terms of the movement of the fortuitous collision of atoms? We might put this question another way, namely, in terms of the possible reduction of biology to physics and chemistry. Is it possible that biology, appealing as it does to teleological notions such as function and purpose, can be reduced to or redescribed in the purely physical, chemical, and non-teleological language of contemporary chemistry and physics? I want to suggest that it cannot, not at least without losing a grip entirely on the notion of a genuinely developmental life process. Our very ability to identify or represent a sequence of events as a developmental life process requires us to reach beyond merely chemical and physical categories. To see this, let's consider a passage written by philosopher Michael Thompson, which I think may just contain the most important point of my lecture. In learning of the various cellular processes unearthed and described in biochemistry, photosynthesis, for example, or the Krebs cycle, or the replication of DNA, one is inclined to think it's all getting boiled down to chemistry and physics, isn't it? And in some sense of boiling down, this is, of course, true and very desirable. But it is interesting that if the only categories we have to apply are those of chemistry and physics, there is an obvious sense in which no such succession of goings-on will add up to a single process. In a description of photosynthesis, for example, we read of one chemical process in the sense of chemistry, or reaction, followed by another and then another. Having read along with a bit with mounting enthusiasm, we can ask, and what happens next? If we are stuck with chemical and physical categories, the only answer will be, well, it depends upon whether an H-bomb goes off, or the temperature plummets toward absolute zero, or it all falls into a vat of sulfuric acid. That a certain enzyme will appear and split the latest chemical product into two is just one among many possibilities. Physics and chemistry, adequately developed, can tell you what happens in any of these circumstances, in any circumstance. But it seems that they cannot attach any sense to a question, what happens next, sans phrase. The biochemical treatise thus appears to make implicit play with a special determination of the abstract conception of a process, one distinct from any expressed in physics or in chemistry proper. To summarize, Thomson is observing that to represent a sequence of events not merely as a chain reaction, but as a genuinely developmental process, we must reach beyond the language of physics and chemistry, because such conceptual resources are required to make sense of the question, what happens next, in the distinct way we ask that question in biological contexts. When we ask what happens next in the context of a developmental life process, we are not asking for a prediction of what will happen given our current knowledge of the chemical and physical states of the universe. We are not asking, that is, about chain reactions. It is not as if our knowledge that an impending nuclear holocaust will wipe out all barn swallows leads us to abandon our judgment that what will happen next for the barn swallow is that it will migrate when winter approaches. When we ask what happens next in the developmental life process context, we are asking about the next phase of an uninterrupted process, which is an unfolding process that it is a unity of phases defined in terms of a goal or endpoint. As I already touched on above, the concept of an interrupted process is critical here. Recall, an uninterrupted process is a unity of phases that succeeds in reaching its goal or endpoint, whereas an interrupted process is one that fails to do so. If we were to restrict ourselves purely to the non-teleological, mechanistic language of chemistry and physics, we could make no ultimate sense of the claim that an impending nuclear holocaust will interrupt the process of migration for the barn swallow. Our what happens next question would have no legitimate application. These metaphysical musings of the last few minutes strike me as rather devastating for any attempt to account for all motion in the reductive, anti-teleological way of a Lucretius or his early modern, anti-Aristotelian mechanistic heirs. Such an admission, though, even if you're inclined to agree with me, does not commit us to Aristotle's global vitalist paradigm. It would be a mistake to apply Aristotle's vitalist paradigm to non-living objects like falling stones, but it would equally be a mistake to apply the billiard ball paradigm of the early modern mechanical philosophers to living objects like growing sunflowers. Where we get ourselves into trouble is in trying to generalize either paradigm to account for all motion according to its favored categories. Okay, so now a final section on consequences for moral philosophy. I'm not sure if I've said enough to convince you that neither global vitalism nor global mechanism are live philosophical options for us. But that's not really my central aim anyway. What I'm really trying to do is shed light on how the early modern rejection of Aristotelian physics and its alternative mechanistic view of motion has far-reaching consequences for how we think about moral philosophy. So what does all this motion talk have to do with how we think of moral judgments? Well, we need to remind ourselves that a hallmark of the modern billiard ball paradigm is the attempted elimination of teleology or final causality from the explanatory categories it uses to comprehend moving objects. Francis Bacon remains one of the most striking anti-Aristotelian proponents of such a purging. He writes, "Teleology is so far from being beneficial that it even corrupts the sciences. For the handling of final causes, mixed with the rest in physical inquiries, hath intercepted the severe and diligent inquiry of all real and physical causes, and given men the occasion to stay upon these satisfactory and specious causes, to the great arrest and prejudice of further discovery. Notice, though, that if we turn our attention to life forms and the judgment that we make about them, a whole cluster of teleological concepts comes flooding back in. Nature, potentiality, actuality, development, natural versus violent motion, function, natural soundness, natural defect, and telos itself. Listen for all of the teleological language in the following example of Hoots. If Hoots flies out of Camden Yards in search of food, it is moving naturally according to an internal principle of motion, the way it is in its nature to move. It is, in other words, actualizing its nature in so moving. If Hoots, however, flies out of Camden Yards because it has been hit by a bat, it's moving against its nature, to be accounted for not by the actualization of an internal principle of motion, but by the action of external forces. Or if Hoots gets eaten as an owlet or vaporized in a nuclear holocaust, Hoots does not actualize its full potential. Or equivalently, Hoots does not realize its telos. Hoots's developmental process or movement was interrupted. If Hoots does not possess the night vision that is characteristic of owls, it is naturally defective. Hoots is not as it should be, whether that is the result of a genetic defect or some external misfortune. If Hoots, though, does possess sharp night vision, Hoots is naturally sound, or as it should be in that respect. When it comes to living things, not just owls, but all living things, we find these teleological ways of speaking to be an indispensable part of understanding and describing what confronts us. Biology, as a science of life forms, and most especially as a science of developmental life processes, cannot get along without at least some modest kind of teleology and its cognate concepts in its explanatory framework. Let's consider the judgments we make about life forms from a slightly different angle. Let's call them natural history judgments. I trust that we have all seen nature shows on Animal Planet or some equivalent program. After a few minutes of watching, we discover ourselves in the midst of a program with visually stunning footage of a remarkable creature that we've just learned is, say, a common octopus, Octopus vulgaris. Among the more striking scenes is what looks to be a greenish-brown, bumpy piece of coral reef against the backdrop of very lightly colored sand. As the camera moves closer to the reef-looking object, it moves, and within a few seconds changes both color and texture to mimic the sandy ocean floor. It becomes clear that what appeared to be a piece of ocean reef was all along a magnificently camouflaged octopus that rapidly relocated and now is only barely visible in outline on the ocean floor due to its ability to imitate the color and texture of its new background. Accompanying this dramatic video footage is the barbiturate toned voice of a narrator saying something like, "The common octopus has the ability to camouflage itself in order to catch unsuspecting prey that crosses its path." Did you catch the teleological language? Consider another judgment. Common octopi, like most other cephalopods, have an ink sac, which can be used to expel a cloud of dark ink in order to confuse predators. The narrator is attempting to provide viewers with a rich, detailed description of the life form Octopus vulgaris. We commonly call such descriptions or interpretations of life forms a natural history. Natural histories are descriptions that identify what is characteristic of a specific life form. The program we've stumbled upon is attempting to articulate the natural history of the Octopus vulgaris. And natural teleological judgments like we've just heard, judgments that articulate the relations of dependence among the various elements and aspects and phases of a given kind of life, are essential to that task. Now, if Ollie the octopus possessed its species characteristic capacity to camouflage itself, but did not possess an ink sac due to some genetic anomaly, Ollie would be naturally sound in one respect, but naturally defective in another. Notice these evaluations. They are evaluations of natural soundness and natural defect. Essential to such evaluations is the identification of the role, function, or purpose various capacities or elements play within a given life form or life cycle. These teleological judgments are incredibly modest, merely aiming to provide the inner natural teleological description of a given life form, and do not, for example, presuppose a divine ordering mind. But they are teleological nonetheless. So, and this is the very crux of what I wish to highlight tonight, if we banish all teleology from our explanatory frameworks, endorsing the reductive project of global billiard ball mechanism, we simultaneously lose a grip on the language of natural goodness and defect. For we make judgments of natural soundness and defect in relation to the teleological relations of dependence that exist within a given life form. That is, in relation to the role played by certain parts or capacities in enabling that life form to actualize its characteristic nature. If a blue tit lacks a round blue patch on its head, such a lack is merely a harmless variation, as blue patches play no apparent role or function in blue tit life. However, if a peacock has a drab-colored tail, it is a genuine natural defect because colorful tails play a specific role in peafowl life. Colorful peacock tails function to attract peahens. A peacock with a drab tail is naturally defective in that respect, and such an evaluative judgment is nested within a holistic interpretation of a life form that articulates the teleological relations of dependence among the various parts and phases of a given life form. As an aside, if these phases really do amount to the unity we apprehend when we represent a process as a specific developmental life process, then we have teleology at a higher level, in the sense that a developmental life process can succeed or fail to reach its goal or end point, that is, fail to actualize its nature. But coming back to the central point, if we jettison teleology from the natural sciences and attempt to redescribe all motion and all natural phenomena like Lucretius or his early modern heirs did, we also lose the language of natural goodness and natural defect. All judgments like Ollie is defective in lacking the ability to camouflage itself, or Ollie failed to actualize its nature when it was incinerated in a nuclear inferno at the paralarval stage, must ultimately be abandoned as mere folk or unscientific talk and must be redescribed in proper mechanistic language. But what, we might ask, does all of this have to do with moral philosophy? Even if we see how the fate of natural goodness and defect evaluations is implicated in the early modern rejection of Aristotelian physics, what does that have to do with the evaluation of humans and their actions? Well, the last 65 years or so have witnessed a revival of moral philosophy in a distinctly Aristotelian key, specifically an attempt to think about moral goodness and moral badness as a special kind of natural defect. Consider one influential formulation of the thought: men need the virtues just as bees need stings. Just as a bee would be naturally defective without a stinger, so a human would be naturally defective without the virtues. Notice that if one could defend the claim that moral defect is a special kind of natural defect, then moral judgments could be as objective and descriptive as the claim that Ollie is defective in lacking the ability to camouflage itself. I won't even begin to offer a defense of such a claim tonight. If you're interested in one, I know of a forthcoming book I might recommend. What I will conclude with, though, are some more wide-ranging reflections. Insofar as we remain captive to the billiard ball scientific picture, evaluations, and moral evaluations in particular, appear to be projections or constructions that are not a part of the genuine fabric of reality. Recall those memorable words of Hume, where he asserts that values are projected onto nature through the gilding or staining of all natural objects with the colors borrowed from internal sentiment. Hume contrasts these with facts that we might discover as they really stand in nature. Such a world picture is one in which there is a sharp dichotomy between facts and values, and according to which values cannot be facts. By contrast, a world picture that includes the modest teleology we've been discussing in the context of living things makes space for evaluations that are very much a part of the fabric of the world. Does the objective description of the universe include value? Not according to the reductive project of global billiard ballism. But if your universe includes life forms and the teleological relations of dependence needed to describe those life forms, and if it genuinely includes developmental life processes or movement unfolding toward an endpoint, then it does include value as a part of what is descriptively there. The billiard ball picture is alive and well with us. It rears its ugly head whenever someone says something like, objective facts are what natural science discovers, whereas evaluations are merely the subjective expression of feelings that are neither true nor false. That picture, though, seen in the right light, is radically unconvincing. Of course there are objective evaluations. Hoots is defective if it lacks sharp night vision. But one doesn't need to adopt an Aristotelian global vitalism to affirm that. All one needs to do is accept that teleological notions are an ineliminable part of the attempt to describe life forms and to explain vital motion. Let us be local vitalists with respect to living things and local billiard ballists with respect to non-living things, and then recognize that that may be just enough to ground objective moral evaluations. Thank you.